Hello, this is checkpoint 2.3 from section 2.1. They want us to find the region between the graphs of the function sine x and cosine x between pi over 2 to 2 pi. So let's draw both functions. We have the sine function that starts at 0 and ends at 0 by the time we get to 2 pi. 2 pi. And by the way, 1/2 happens here, or pi over 2 happens here. And this is 2 pi. Those are going to be our limits of integration. Now let's draw the other graph. The cosine starts at 1 and it hits the axis at pi over 2. It has a minimum in the middle. They cross here, which is going to be important for us. And then they come back up here. So this is the cosine function. Now they want us to find the area between here from pi over 2 to pi, and in some of the graph the sine function is higher, and in other parts of the graph the cosine function is higher. So we have to know when to break this up, when the sine of x is bigger than the cosine of x, and when the cosine of x is bigger than the sine of x. So it looks like the important number that we want here is this number, which is where they split up. And so they intersect at a couple of places, the sine and the cosine. At pi over 4 in the first quadrant, and then they're both negative in the third quadrant. And so if we follow the pi over 4s walking along the unit circle, pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and 5 pi over 4 is when they will both be equal again in the third quadrant. Okay, so our formula kind of gives us something with an absolute value. So the area is going to be the integral from pi over 2 to 2 pi of the absolute value of the difference between them, sine x minus cosine x dx. Now, this is saying sine x is first. So from pi over 2 to 5 pi over 4, it'll be sine x minus cosine x. But then after that, it switches, so it'll be the negative of this, which is positive cosine x minus sine x. So really your area will be equal to the integral from pi over 2 to 5 pi over 4. This is where they intersect again, and this is where the sine and the cosine switches, being larger. Then the first part, from pi over 2 to 5 pi over 4, we have the sine x minus cosine x dx. And then after that, we're going to integrate from 5 pi over 4 to 2 pi. And then this time, it's the negative of this, so we can just write it where the cosine is larger than the sine, or it's a difference, cosine of x minus sine x dx. Okay. One of the things that you could probably see is that they're symmetric. If we stop here and here, then these two areas look like they're going to be exactly the same. We'll kind of see that in the integration as well. But that's just something to look out for. If we just find one, we just double it and get the other. But like I said, we'll see it. All right, let's take the antiderivative. The antiderivative of sine is negative cosine. Let's remember that they switch signs. And then we have a minus. The antiderivative of cosine is positive sine, but there's a negative in front here, so the sign does not change. SIGN, sign does not change. And we're going to integrate this, or evaluate this, from pi over 2 to 5 pi over 4. All right, let's continue working on this side first. Cosine of 5 pi over 4. It's a negative, so negative is a positive, so there'll be a positive root 2 over 2. And then we have a minus, and then the sine of 5 pi over 4 is also negative root 2 over 2, so let's call it a plus root 2 over 2. And then we'll put pi over 2 in there. The cosine of pi over 2, we see the graph here, the cosine of pi over 2 is 0. And then we have a minus, and then the sine of pi over 2 here is 1. So we have 1 positive, because there's negative, negative, so that's a positive. And then root 2 over 2 plus root 2 over 2 is 2 root 2 over 2, which is root 2. So 1 plus square root of 2. All right, so that's the area here. That's the first part. And we'll see that if we do the work here, we'll get the same result. Let's just go ahead and do it. The antiderivative of cosine, remember, is positive sine. And the antiderivative of sine is negative cosine. So there's a negative in front, negative cosine, so that's a positive cosine. And we're going to evaluate this from 5 pi over 4 to 2 pi. So sine of 2 pi, sine goes back to 0. Cosine of 2 pi, there's a plus here. Cosine of 2 pi is a 1. And then we're subtracting sine of 5 pi over 4. So we did this already. It's negative root 2 over 2. And the cosine of 5 pi over 4 is also negative root 2 over 2. So again, this is a positive because of this negative here, negative, negative. So this, when you add them, you'll get root 2. And then negative root 2 times the negative is positive root 2. And then we still have that 1. So here's the other one. So we'll add them. It'll be 2 plus 2 root 2. Okay. All right. That's it. Good luck.